Hello everyone, welcome to the webinar series of Mastering Microseismic and Geomechanics, the fourth webinar of this series. My name is Junwei, I'm the moderator of this webinar today. Today's speaker is Devin Garrett. So he's currently involved in developing the induced seismicity and microseismic tools for IMaGE. And prior to joining IMaGE, Devin worked as a microseismic specialist for Schlumberger and ESG solutions focusing on both induced seismicity and downhole project. He has a bachelor degree in geological applied science from Queen's University. So now I'm going to turn over to Devin.
All right. Thanks, Junwei, for the introduction. And welcome, everybody. Good morning or afternoon or evening, depending on where you're listening in from. Thanks for tuning into our webinar series here. So this is the fourth part in our series, and I'll cover the microseismic image quality control and reprocessing, if necessary, of data. So as Junwei said, if you have questions, please just type that into the chat, and Junwei will get to them, and we'll probably answer them at the end, but if we see them earlier, we might take note of them sooner. All right, so just a quick outline of the webinar today. I'll do a brief review of the previous webinars in case anyone's missed them or forgotten about it, and then go into what's the next step from there, which is really QCing the data. And we'll look at a handful of different aspects to check and hopefully answer the question of does the entire data set need reprocessing, or if it's just a select few outlying events. And from there, we'll compare the final results and wrap up the webinar for today. So previous webinars have talked about microseismics in general and really focused more on the survey design and feasibility and project setup. So that was a webinar delivered by Junwei a couple months ago. Then the third webinar in our series, again delivered by Junwei, was more about data acquisition, triggering, and then sensor orientation, velocity model calibration, and finally picking an event location. So I'm going to touch on some of these aspects again in QCing, mostly the project setup, sensor orientation, velocity model calibration, and picking and locating the events. So I'll give a brief review of those again later today. But if you really want more in-depth about information about that, please view the videos of the previous webinars. All right, so you've been delivered a data set, or you just finished processing a data set. You've got a bunch of waveforms that have picks on, similar to the one in the left, and you've got an image of your results and your events scattered throughout, like the right. So what's the next step? How do you know that these results are accurate and you can do interpretation on, or how can you analyze them to see if you need to do more QC work on them? And really, yes, the next step is to find out if you need to do any quality control. And you should do this for every project, no matter if your results look really good, similar to the image here, very linear events, clusters, they all start on zone, they'll be at the correct depth. Or if you get a project and the results look like this, where nothing's on depth, they seem to be on boundaries, shallow, or just shotgunned all over the place. Both of these projects should be QC'd and looked at just to make sure everything was done correctly. So one of the major tools for QCing is to look at any calibration shots you have. So whether that's perforation shots, ball seats, string shots, anything that's downhole near the formation of treatment, you want to make sure that these events are locating near their actual locations. So in this example, you can see perforation shots from 6 stages of one treatment well. And for the most part, they all locate quite close to their actual ports, off by a handful of meters, but nothing too significant. So this is a pretty good idea that things were done correctly, at least when processing the calibration shots. You still want to make sure that your data was processed using the same settings and picked the same way as these calibration shots. But sometimes you'll get projects where you'll have your calibration shots won't be anywhere close to your treatment well. This is an extreme example here, so hopefully no results like this, at least no final results. But you can see they're all offset from your treatment well, and that screams something's incorrect, or maybe they're just all over the place, like this example. Again, another extreme scenario, but something that just shows that your calibration shots aren't where they're supposed to be, so something has gone wrong in processing your data. So I'll go through a few of the common sources of error here and help show you what to look for if you're reviewing a data set or if you finish processing and kind of want to know what might have gone wrong. So one of the first things to check is your project setup. Then you want to look at the orientation of your geophones in your array. Check out your velocity model calibration to make sure you're using the correct velocity model for each stage. You want to look at the picking of your events to ensure that they're all picked consistently and correctly. And finally, just make sure you're using the correct processing settings from your different velocity models, your picking, your orientations, and all of that to make sure you're doing it correctly. So these are just some common sources of error. There are definitely many more, but these are some of the most common ones, and I'll go into more detail of them right now.